data science, visualization, machine learning, and I also do a lot of rich internet applications and advanced UI. And I promised to explain, I want to introduce the concept of something that hasn't happened yet. And I want to put in your mind the idea that to give a variable that contains something that doesn't exist now, but it will down the road. So I can say that I'm going to give you an explanation, I'm going to give you some examples, and I'm going to help you understand this. And then you can go ahead and just pretend that I've done that already, because, hey, you've got these variables now. So, given how bizarre this is, I wanted to give some background on sort of how I reached some of these methods. And this is all coming from the domain of asynchronous programming, where you have several different problems. You have client code such as JavaScript, Flash. It's all single-threaded. You don't want to block that thread. You don't want to have too much calculation going on. So you're constantly breaking up some of the calculations and spreading them across multiple loops. You also, being a client application, you're typically waiting for a server to complete something. So you've got a delay there as well. Some other problems that you run into is that you have to really be careful with catching errors in several locations spread across all of these different functions, because they occur on different loops and they break out of try-catch blocks. And in all these cases, typically when you're invoking these callbacks, you're following nesting patterns that cause you to lose your width of your available width for your code. This can make the code really difficult to read. And finally, this is happening on the client and the server side. Kind of from seemingly out of nowhere, JavaScript's now on the server through Node. Has a lot of these same problems. And so one of the other things we want to do here is come up with a way of managing all this asynchronous behavior in the same way, so we don't have to maintain little minor differences in client and server code. So as an example of what the conventional callback approach would look like, I've given this sort of contrived example. But just kind of read through it and just think in your head how many things are wrong with it, and in terms of how it looks and maybe potential errors that it might have. And just in these couple lines of code, it's really ugly to read, and there's a lurking error, and there's some other problems with duplication. So of course you're losing space due to indentation. Because you have all these chain callbacks, you're losing the try-catch block every time, so you have to retry, recatch. So in one case there's a missed try-catch, which you might not notice. Also, when you're wanting to move calculation into the next loop, you're typically using, you could be using the conventional Haxe timer delay, which is basically set timeout in JavaScript. But even when you set that to 0, it's not 0. There's always some small delay that's going to occur. So it's never going to be exactly the next loop. And even though you miss error handling in one spot here, there's, even if you cover every possible place where you need to catch the error, you're duplicating that same call over and over and over again for each callback. So it's just a pain. There's a ton of boilerplate for this. So I really think the solution is reactive programming in different techniques. And it's basically the principle of data flows and propagation of change. And I'm just kind of cribbing from Wikipedia here. And you want to have the ability for changes to propagate. So you kind of want to lay out a scheme for the data to flow through, and then you want to, whenever you get an update, you want to trigger the next process that needs to run. So reactive programming moves the unit of asynchronous programming from a callback to this special object that we're going to use. And this special object is really best understood as a variable over time. So keep all that in mind. So let's take a look at this variable from a very high-level conceptual perspective. We'll look at any code. And it's literally, we'll start just with a container. In that container, we've got this value. And it's like Schrodinger's cat. It might be alive, it might be dead. We can't really know. We just know that it's going to be some kind of cat. And we have the ability to resolve that value almost as a pipeline. So we can pass in some value we want to resolve, just x, for instance. And then everything that's depending on that value downstream can attach its own listener to a then function, which is sort of the trigger by which downstream variables get updated. So this gets propagated into the container now, and then the container updates everything downstream. And obviously, this is these reactive objects also have this notion of time, and time here is just we want to break things up into loops. So there's loop n and loop n plus 1, and the object's going to span that. So the data comes in on one loop, but it doesn't actually trigger updates until the next one. So it's sort of like punting, or it's delaying the process and then updating everything that needs to happen next. And the mechanism by which it does this, I've added some special handling for JavaScript, because JavaScript's very sensitive to this sort of thing and has a lot of use cases. I already mentioned that in the example that set timeout, even if you set that to 0, it's not 0. It's not going to go on the next loop. It's got a baked-in delay of anywhere from 4 to 10 milliseconds, which doesn't seem that long, but if you're going to be doing this over and over and over again, especially for UI-related routines, it'll be noticeable to have what the delay is as small as possible. There's other ways you can put things into subsequent frames in JavaScript. Request animation frame is one of those. But a lot of these methods have drawbacks. So request animation frame actually will also request a repaint, which you don't necessarily always want. So that wasn't a good idea. So one of the new features that is not widespread and it's not well supported yet, but it's called set immediate. And this basically is kind of cuts to the chase. It can put an execution context directly in the next loop, and that's exactly what we want. So that's what I'm calling this, is this set immediate routine in JavaScript. And then luckily there's good polyfills for this that will support older browsers. And this is a side note, this was done by a project at Barnes & Noble, so it's called Noble.js, that provides this polyfill. Other platforms outside of JavaScript and outside of a few targets that don't have conventional set immediate type handlers, you're expected to bring your own event loop. So this can be your own, if it's some kind of a game, this is your world next tick type method. Anything that you're using to drive the timeline forward. So I have a way of plugging that in. There's a class called event loop, and you just give it a method that you use to handle your next loop. So now that I talked about how values resolve over time, you can extend that notion to how values can be chained together over time. So you can spread out calculation over multiple objects, and by doing so, you're separating things out in time. And so values can come in to one object and be resolved directly into another one. And you can set up chaining, which seems simple here. I'll give some more examples. So it's very simple. You're going to resolve this value, and that's going to get passed on to the next object, and so forth. So now I want to talk about a specific case of a reactive object, and it's a promise. And promises are becoming popular for handling initializations, where you need to go out and retrieve maybe some content from a server, or it's as part of a configuration process, and you want to say, this configuration will be here, and I don't want to do anything until it arrives. So it's promises are a proxy for this result that's initially unknown, and it's because it's not yet complete. It's because it's waiting, or because maybe something else is holding it up. Pass that to a stream, which is almost identical to a promise, except it can result multiple times. So a stream might be more analogous to a series of mouse events as you're moving a cursor over a screen. It's sending you the coordinates. And with the stream, it's letting you handle things one at a time, rather than bulk updating all of the previous coordinates at once. You get them one at a time, one per loop. So talking about promises versus streams, as I was saying, this is basically just recapping. It's good for initial configuration. They can only resolve once. That's really important. It's kind of sort of a contract by saying you don't want to read configuration twice and kind of mistakenly initialize your application twice. Streams, on the other hand, they're designed for being more general purpose and having fewer restrictions. They're designed to resolve more than once. Both of them together, you can generally substitute a promise for a stream is expected, because streams are less restrictive in terms of what they accept, but not vice versa. And by putting them together in the same framework, I'm giving them the same error handling semantics and that same asynchronous event loop handling, so that they're both very efficient. They both kind of play by the same rules. You can reason about them in the same way. And importantly, both use Deferreds as a writable interface. This is brand new. The version I'm talking about is 1.0. And Drive, I don't know if he was here. We were talking about that earlier. So this is a very recent addition. I went ahead and added it in because it was going to be a breaking change, and I figured I might as well talk about it. So just talking a little bit about the deferred, this comes out of the need to protect an object from other methods that could potentially write to it. So you want to make sure that other external third-party code can't write to your stream or your promise and update it without you knowing what's happening. So the basic mechanism is rather than constructing a promise directly, you construct the deferred first, which is sort of like your way of writing to it. And then you give the deferred to the promise. And by doing so, you can still write to the promise, but no one else has access to that interface. So it's protected. And as sort of a visual for this, if you have a reference to that deferred, you can write to it and trigger all the then updates. But as a promise or as a stream, etc., it will no longer have a resolve method on its own. With one exception, there's still a class called public stream, which lets anything go. So you can pass that around, and all kinds, code can resolve it. So I just wanted to show, I talked sort of the high-level abstract. I hope some of that was clear in picture form, but in code form, just wanted to give a contrast in terms of what the two different approaches look like. I don't know if this is so legible, but here you've got a typical jQuery statement. You want to wait. You want to wait for it to be focused, and then you want to call this callback. With reactive style, what you're going to do is this is actually a method I defined. It's a public static method, and I applied it in jQuery with using. But you can imagine, a similar method applied for different means. It's just what it's going to do is it's going to create a string of focus events on that element. And so once we have a reference to that stream as this reactive variable, then we can attach the then handler to it
and pass it around in multiple methods, use it in multiple different places. We can use that object to handle that event. And then I also wanted to talking about handling that reactive value. There's the instance interface, which is the then method. There's also a static interface, which is a little blurry, but you can see it down here. The instance method obviously acts on itself. The static method you can pass is called when. So Promhx has a method called when. Stream has a method called whenever. And what it's trying to say is that when all these values have resolved, then act on them. So this is a way for you to gather. This is where like reactive programming starts to become a little easier to deal with, because now you have the way of setting multiple variables and then waiting for them all at once. And inside the callback here now, rather than these being these variables here, this is a macro method. These variables now will be the unwrapped values that those promises held. So you're able to kind of switch back into conventional variable types. So in this case, we're just tracing them out. But the nice thing about this is with macros, you can put as many promises as you want into that signature, and then you get them out in the exact same order with the unwrapped type. So it's just a nice convenience method for managing promises in bulk. I also want to talk about error handling, because this was another problem. Promhx comes with an error handling mechanism built in. So if something goes wrong, what happens is you don't actually get an error on that function. It's caught and then passed on down the chain until one of two things happen. One is it hits a special method, a chain method called catch error, which will catch anything that's happened prior to that point. Or it reaches the end of the chain, and then the error will be thrown. So you can set an error handling method wherever you want. If there's a number of steps where you don't want to be explicit about what the error type is and you just want to catch it, you can insert this error method in there, and you can be confident that if something goes wrong anywhere in that chain, that you at least can respond to it and restart or call some other callback. So it's sort of a fail-safe for all of these reactive objects. Promises and streams both have that. One other way that you can recover from an error. Well, here I'm just going to talk about what this looks like visually. I'm sorry. So what's going on is that there's this bypass that happens between the two values, and it no longer goes to the conventional then and resolve step. Now it's going through a private link that exists between these two objects. And when we have step to this, when one instance receives an error, it's going to pass on that error to the next object. But this object has the catch error defined, so you'll be able to act on that error inside that method. The other method you can do, catch error is just sort of like the chained equivalent of a try catch. It's just going to halt the process. One way you can recover from an error is maybe you have like a really horrible server response, or you have something weird happen, and you want to say, in that case, if something happens, I still want to return a value of some kind and pass it down, some kind of dummy value, some kind of message. What you can do is you can use error then, which is basically like a then statement, except the input is no longer the resolved value, it's the error. And then you can map that error back into a valid type that can be used downstream. So you can do this wherever you want in the chain, and it's just a way to just gracefully recover from an error condition that happened at any point in the chain. And here's an example. Rather than passing the error, so the error will happen on the first object. Rather than passing that on directly, the error then will map it back into a normal value and then pass it to the next object as if it were a valid call. So it lets you recover. One of the other things I'm going to talk about was the concept of promises and streams as monads, and this is like a pet discussion topic of you find countless blog posts on this, like people talking about how great monads are. I can't go into them too much, I'll spare you. But I just wanted to go over like why the streams and promises are monads. They satisfy all the requirements. They have a type constructor, they have a unit function, they've got a bind function. And they're useful because you can provide new capabilities for a type. You can build on this concept of promises and streams. And still let the original functions use the new capabilities. You can capture operations on the types, making it easier to build more complex compositions. And you can represent the side effects more cleanly. So it's one illustration of this, like one way I started playing with this was using a library called Promhx, which uses lets you use monadic do notation. So here in this case, it's letting me. This is a really simple example. It's letting me bind values from a string. So the bind method here is basically the then method, but it's letting me write this as if it were an imperative style using monadic do notation. And then at the end, I can resolve all these strings at once. So it gives a nice, clean implementation of how to chain promises together. Just kind of repeating what I said there. And this is a very trivial example. You can make these as complicated as you want with as many methods. All the methods just need to return a stream type or a promise type, whatever modad you're in. So I wanted to talk a little bit about, kind of why I think this is important with composability. To me, this is sort of like a composability versus standards fight. I think this is something that as hacks, we always try to support standards. But I think that there's a little bit of a disconnect happening here with the way that JavaScript is going with promises versus the way that I think promises are understood in terms of category theory and with monads. In JavaScript, you've got this callback usage that's predominant, and you've got the question of like, should we follow a standard from a specific language? So I spent some time and I really looked into what these specs were doing, and one of the things that I was struggling with was how complicated some of the logic was for resolving a promise. And part of the problem is that according to the spec, whenever a promise is resolved, the spec says that you should inspect the value of the promise and then change the behavior based on what the type is. So if the promise is another promise, then you have to adopt the behavior or adopt the state of that value, which is basically it's kind of hard to say, but it's preventing you from doing conventional flat map or these types of operations that let you do the do notation. Because if you're changing the value of what the promise resolves to, then you can't really reason about it. If you're changing it conditionally, you're just basically saying that you can't have such a thing as a promise of a promise, which is like saying you can't have an array of an array, which is strange. So JavaScript's flattening that out, which I don't think it might make sense for them, but in the context of this, in the context of how Haxe has a much more robust way of managing generics and types. I don't think it makes sense for us. The other thing is that it treats the mapping operation for then. It's conditional depending on whether or not it's a function. So it changes behavior again if it resolves to a function and then it just applies that function. So it's kind of some strange behavior, and I think it makes the spec harder to understand and harder to implement, and then harder to reason about, like, what will happen given some unknown value that you're trying to resolve. If it ends up being a promise, it'll change behavior. If it ends up being a function, it'll change behavior. So I'd rather keep things simple, keep the mapping simple, so that it's predictable. You always know what value is going to come out the other end, and kind of go with more of a kind of an eye for composability. So, there's a lot of other libraries out there that do promises, and I think everyone's going to kind of choose what makes the most sense for their community. And so I wanted to be clear, like, which direction I'm not going, which is with this spec. So on the other hand, the direction I did want to go was I didn't want to have something that was well tested. So I've got a little bit over 30 individual tests on 7 platforms for Promhx. I've got 2 of those platforms have some significant problems. One of them might just be a problem with the testing framework, and the other one is PHP. Yeah. It's also, sorry, Franco. No, the other thing that Promhx is really good at is that because I have all this special handling for the event loop, trying to make that as efficient as possible, it has a very nice performance. I took this snapshot intentionally when it was winning, so this is it's still performing quite well, but I've since added some features that I think have slowed it down a little bit. So I'm playing with that. I don't think I don't think it has the crown anymore, but it's still very, very fast in JavaScript. And really that's it. So I just wanted to cover the points again, talking about why we need better asynchronous methods, or better methods of handling asynchronous behavior. I'm going to talk about the basics of functional reactive programming, how they work, explaining it from sort of a higher level abstraction. I'm going to talk about the basic types of reactive programming that Promhx supports. So that's the promise, the stream, and the public stream, and the way that I'm using Deferred as a special writable interface so that it protects those streams from updates that might occur from third-party code. And then I talked about the way that Promhx handles errors, sort of gives you this safety net, so that you can know that you attach an error handler on it and be sure that you're covered. And the way that it handles the loop behavior, optimizing the way that the value is passed on to the next loop. And then I talked a little about how the promises and streams really are monads. And since they're monads, we can do a lot of cool things with them, including the do notation. I also talked about why I kind of want to stick with that pattern, and even if that goes against some of the standards that are coming up. And then I talked about the speed and the how well tested the library is. I say well tested. This was my first time using Travis as well, and I highly recommend, if you're going to do any cross-platform code, to put your money where your mouth is and just try to have a testing solution for all those targets. And I think you'll be surprised. There's still some nooks and crannies where you'll have failures and you kind of have to dig in. But generally, it's just some quirk that you need to accommodate, or maybe you can find a bug or something. But that was really helpful to me, and it exposed a lot of flaws, and most of those flaws are fixed, so the library is better for it. And that's it. I'll take any questions.
about the try-catch problem that you talked about. How come it isn't bound to the outer closure like it's intuitively supposed to be?
Mm-hmm. I think it's something. It's the try catch operates on that scope or on that block rather, but since the inner scope for the callback is actually occurring in another loop, it breaks out of that handling. So you have to apply try catch at each time you have a callback in JavaScript. So it's just the way that mechanism is designed. So I can't really speak to why it is, but it's just the reality of writing code that way. So
it's language dependent, JavaScript.
So as far as I know, that's pretty typical. I can't think of a case where that's not true. But I was really biased towards JavaScript, so I tried to focus on that and cover all the bases there, because I think JavaScript can get really weird. You've got a lot of older implementations, and I sort of wanted to try and address as much of that as I could with polyfills. It's just client-side JavaScript is by far the hardest part of this to crack. So, and then having something that was consistent client and server side was important for JavaScript as well. But for the rest of the targets, they're pretty straightforward. They don't have as many quirks. So, at the same time, I haven't really investigated if there's any other strange behavior, because they're not necessarily. I mean, the tests are all passing, and they all seem to be much better behaved. So.
Can you say something about how to deal with the progress in, for example, HTTP loading or something?
Yeah, that's a really good question, and I really thought hard about this. And I think I couldn't hit on I mean, progress could be considered in a number of different ways. You could have like a ratio towards completion, 99%. You could also have a phase of a response given in terms of like a stage or some other kind of monotonic indicator. So in either case, there wasn't really a global kind of standard I could look to, and I ended up solving this problem. I don't have an example on a slide to show, but just a combination of streams and promises. The promise would be a payload, and then the stream would just be the indicator for whatever it was, whatever you're trying to communicate. It could be numeric. It could be that number from 0 to 1, or a message or something like that. But to me, it just seemed like the cleanest way to compose things would be to use the two together. So that's kind of how I'm moving forward with that.
Okay. Thank you.
Mm-hmm.
I'm kind of not convinced in using the stream for high volume events like a mouse move.
Mm-hmm.
Do you really think it makes sense, or is that because Chrome, for instance, doesn't have a set immediate, so it's like a set time of 0, which is not that good.
It's not, but Chrome has. I can't remember the name of the method. It actually has the polyfill addresses the lack of set immediate in Chrome, so you get it. And for things like mouse move, I think it's still useful, because what'll happen is it all depends on what is listening downstream. What you don't want to have happen is you don't want to have a lot of activity blocking an update. So anytime you have an update, it's going to be moved to the next frame, and move to the next frame, and move to the next frame, and give that mouse and give the UI interaction a chance to catch up.
Yeah, you might get like 10 mouse move
Mm-hmm.
callbacks or maybe they will be split, or maybe they will be buffered, and then you get 10 frames of mouse move, although you have stopped moving. So that's the point of this accumulation of delays and callbacks, which is a bit worrying.
Mm-hmm.
If you had an intense string of response, would that spread into that many frames?
Yeah. So I think by the nature of streams, I don't throw anything away, or I don't. Things will accumulate, and they will be staggered across the frames and staggered across the loops and be executed as fast as you can, as they can be executed. If there's a condition where you want to stop responding to a stream, you can detach the stream. I didn't show that here, but there's ways you can turn it off, or there's ways you can pause it. So you have the ability to control how much of that you actually listen to as a developer.
Well, I mean, maybe it might make sense to have like a synchronous stream that wouldn't be have delay.
Mm-hmm.
If you want to have a nice promise pattern, but you don't want to include the delay, so you have synchronously all the events pumping directly.
Yeah, and I think I agree with you. I think that the in terms of the number of events coming out of a mouse event, you would need to slow it down. You would need to maybe set some kind of a limit. But once again, you can, with streams, you also have the ability to filter. You have the ability to pause and unpause and end the stream. So I think you take that case by case, and maybe that's not the most elegant solution as using a raw stream. But because streams are they're monadic, you can easily just add another method on there and filter out the ones that you don't want. You can delay them, or you can do whatever you want.
Is filter synchronous?
So filter was, I believe it's synchronous. Yeah, it's synchronous.
Well, it should, hopefully.
Yeah.
Okay, another question. I'm trying to use Promhx actually. I'm using it, but I would like to avoid the Promhx dependency.
Mm-hmm.
So would it be possible to split Promhx into the core Promhx without the Promhx, and have a second library to introduce this dependency?
So I have the dependency there. Promhx is actually pretty small. So, and it's all of the methods for managing the do notation are in a separate class.
Yes, but it's for some other technical reason. It's because Massive, we have our own package manager,
Mm-hmm.
its own dependency manager,
Mm-hmm.
and to easily integrate a third-party library, we need to. It makes it a lot more complicated when it has dependencies.
Yeah, I kind of wish there was a mechanism that was like a suggested library that would just install by default in normal modes. But yeah, I could look into splitting that off. Right now, there is a lot of like batteries included, just because I kind of want to show it's supposed to be sort of a gallery of the different things you can do with it. But yeah, I don't really have a problem with splitting that off as a dependency. So.
Couldn't you just use a -d, conditional compilation?
Yeah, I think that might be the way to do it. But I mean, I declared a dependency in the Haxe though, so I need to take that out and then do some kind of a conditional.
Take out the exit dependency, and if you're using monad in your project, re-enable those.
Get it back, yeah. I'll probably do something like that.
Hi.
Hello!
Franco, I'm sorry. I want to apologize publicly for my remarks about PHP. I usually...
Actually, I do have a question. So, okay. So, can you create promises with multiple arguments?
Multiple, sorry?
Arguments. RET different from one?
You just need to wrap it in some kind of an object container.
Okay, so and how do you distinguish between promises with one argument and promises that resolve with no arguments?
Promises that resolve with no arguments?
Yeah, like I'm done. I don't need to communicate any value, I just need to communicate the state.
So promises have a guarantee that something is going to resolve as part of the deal. So it's part of the contract for a promise, and there's but streams actually don't have that guarantee. So one of the things that you can do is end a stream, and when you do, you get one final update on that stream, and the update is the option type, and the option type is either the last value that it resolved, or it's empty. It's saying that this never happened. So yeah, but there's some details there. Like, I know that some other people wanted to be able to cancel promises, and that is it's a mechanism that doesn't exist in other libraries, and I'm looking into that. But it's sort of it muddies up the contract of what a promise is supposed to do. So and one of the nice things about promises is that it guarantees that things move one step forward. You know, that you can kind of assume that this has happened now, and you can go on with the rest of your code, assuming that this promise has been delivered. So when you start breaking that, then I think I need to make sure separate that out as a different behavior, a different class, or something like that.
So do you have any finally statement or something like that?
Not right now, but yeah, that's something I could look into. Like I said, it exists in other libraries, and I think that could make sense.
Okay.
Yeah, just about the promise that resolves to nothing. I think the best thing to do is just to define a type that represents nothing. Like I think it's called noise. But you can also pass an empty object, and then if things change, you can still start adding arguments, you know, and the client code doesn't depend on the absence of an argument. Like you could turn it from a signal 0 to a signal 1, because you need to pass information, and other code stops compiling. It's much better to say, okay, a signal has an argument, and just a single one, because otherwise you can't map. Like, how would you map a signal to? Okay? Mm-hmm. You can't really, because the mapping function can only return one value. And the same goes for 0 arguments, just return something, like you can return the object that just resolves the promise, like when it's a button, just return yourself this, or something, just return something, because it might become meaningful. Mm-hmm. Or make it an empty object, and as soon as data comes out, you can add it, and other code doesn't break. Mm-hmm.
Yeah, I think it will end up looking a lot like how the error management works, where it's something that kind of operates outside of the context of the monad, so you can't really cover a cancel inside there, but you can have something at the very end and say, oh, by the way, if I get a cancel message, I know that I can close a connection or do whatever else I need to do. So, but we should talk about that, because yeah, there's a lot of disagreement on promises, and I've tried to fit as many different